first thing you're going to have to do in your assignment is a reinforcing bar schedule, which you can see down the bottom there. Looks something like that. So I'm actually going to copy that onto my whiteboard here. So for those that are seated sort of in this region, well done. You're going to see the answer come before your eyes. For those that are seated over there, well done. I'm going to be working through it bit by bit over there. There's that interesting stuff. We wouldn't want to rub that out. There it is. I will get rid of whatever's there. No. It's been, it's already been dealt to. Well, there's a trick to this. If you draw over what someone's got on the board, it rubs off. Did you know that? I'll show you that. There we are. So over here I'm going to do my workings, and over there I'm going to put the answer. So basically you can take a photo of everything at the end if you like, or you can write down things as I'm doing it. Well, that didn't work, did it? Well, good old fashioned water. That's good. Oh, that's probably a clean enough board for me to carry on doing what I was going to do. Alright, so up there you see that we have the location, the bar mark, the number of barley, mass, weight, and sketch. So here's a question, and those that were in the lecture this morning are probably going to have the best chance of answering it. Why are we trying to find the weight and the total weight down the bottom as well? Anybody like to have a crack? Yeah.
To know how much it's going to cost.
Yeah, too right, 100%. It's a shame I didn't say that the half mark, eh? That's a half mark for the gentleman at the back. As long as he emails me before 12 o'clock tonight, and he's on his email already, didn't take long. Okay, so it's exactly right, and it's how we price the reinforcing. So there'll be a price per weight, per kilogram of the reinforcing, and as engineers we need to know a rough idea of the job and the cost. So yeah, you'll end up having to get a total weight, and then you can apply that to the cost overall. Of course, there's also labour, which has to factor into everything as well. Now, before I start this, which I'm just about ready to go, I need to explain that in the engineering world there are construction companies, and there are also consultancies. You know, that to second language students, that sounds like the same word. It's not, it's very, very different. Construction companies, they do the building. So often, they'll take the plans from the consultancies and they'll build it. A bit like an architect and then a builder or a chipper. Alright? Sometimes construction companies have their own, they employ their own engineers and their own, and they do the design and build. That's called a design and build job. Whereas quite a lot of times in Auckland, a construction company takes the plans, they might have one engineer working for them who interprets the plans, and they'll have the builders, etc. that build it. And of course, trucks and diggers and rollers and all those other things as well. Reinforcing companies do the reinforcing, Sometimes they will do their own reinforcing bar schedules, in which case the consultants, all you'll put on your drawings is D16s, 16mm bar, D16s at 300 centimeters. Done. Your job's done, you've done the design. You're not cared about how it fits in the concrete. That's all you do and you move on to your next job. Obviously you're not going to get paid much. The reinforcing guys will have an engineer working for them or a engineering technician, and they will work everything out like you're doing now. So it's a little bit confusing in that the way how it operates in New Zealand. Sometimes consultancies do this, sometimes construction companies do this. Alright? So it just depends where you end up working, but it's really good to have a working knowledge of how it all works. We were working for the Saudis over in England, and the Saudi Arabians didn't want to have a bar or a little pun on that one, by the way. So they said, you guys do it. So we did all of that. They didn't have the engineers or anyone that wanted to do that side of things over there. So we did the whole lot and handed it over, and somebody else built it over in Saudi Arabia. I have worked for consultancies here in Auckland, and the only thing they either do is put D16s or D12s at 250 cents. Revit, when it draws reinforcing, it doesn't really give a decent bar schedule, and it also doesn't really do reinforcing to a great deal of detail. So it is possible that you're going to have to do proper detailed reinforcing drawings in a consultancy in New Zealand, at least until ChatGPT or something ends up working out how to do it. And this is one thing that students find really hard to cheat in, because you can't go, hey Google, show me how to do this. It's kind of a skill that I'm teaching you that you're going to have to try and get your head around. That's what's important to turn up to today's class. Right, so I'm going to turn around and I'm going to start drawing that sheet up here. So what it is a location. And then the next one is, of course, the bar mark, which is made up of the diameter and the number. The next one is the bar length. Oh, sorry, number off. Number off is a fancy way of just saying how many. We're going to work that out. And I can guarantee you, when I first start doing it, you're all going to get it wrong. Bar length, hopefully you'll prove me wrong. Bar length. And then after that we have the mass per metre and the weight overall. So mass per metre, the weight. And over on the far side here we're going to do a sketch. So let's have a look at what we've got, and I'll just summarise it. So it's kind of a T-shaped retaining wall. The ground is over here. So when the ground is over here, this is the bit that's open to the ear. So when we talk about each face and far face, we're looking from this side. We're looking from the side that's not being retained. So therefore that would be near face, and that would be far face. But because we've got them on both, we call it each face. Now there's abbreviations for those, and they're not too hard to remember. Near face is NF, far face is FF, and each face is E. Yes. It's not very hard to mark, by the way, but it's very, very quick. So you're going to have to put that abbreviation into here, and I'll do that in a second. The next thing to look at is that when I do a sketch, it is only a sketch. Alright? Do not copy it. Think about it. With reinforcing, it's exactly the same with bolts, and it's exactly the same when your grandmother used to do the quilting of the thing that's on top of your bed. Where did she stitch it? Did she stitch it in the middle or right around the very edge? Come on, own up. Who's done quilting before? No? There's no real men in here, is there? No. No all black potentials? No? Okay. So, quilting is a thing where you make kind of like a duvet, and to make it the proper strength, you do the stitches around the outside. With reinforcing, we push the bars right hard against the cover. Now this morning we talked about the cover and the reason for it. For example, yeah. Beg your pardon? Yeah. Yeah. So we've got to push the reinforcing to the edge, not over the cover. So it's against the cover. If my hand was the cover, it would be right there. Okay? And that's how we work out how, so for example, this piece here, the sketch shows me it's inside here. So this is all 400 all the way up, but there's no reason why that bar can't go in behind the other bar, which means if we push it against the cover is up the top there, 50 mils. So that will be 400 minus 50 minus 50, and that's what it would sit hard against. So we already know the width of that bar is 300. The only time when you can't push it against the cover is if there's another bar in that direction stopping it from going any closer to the cover. So there are times you have to think about it. Same with these. Even although I show that in the sketch as being overlapping, in actual fact both bars are in behind each other, they're exactly the same, one's upside down, and the cover is 50 mil, so that would be 2000 minus 50 minus 50, and that would give me the overall length of that bar. So it is fairly basic, the math, it's not too bad. But you're starting to get the hang of what I'm talking about in terms of pushing it to the outer extreme. This one is an old exam question. When you had to sit an exam in the subject back in 2010. So it's got a few other things here, like they call that binding concrete, which is kind of like a builder's mix that gets thrown down there before you start the job. It's got some drainage, which you have all got, or filter material, and a drain, and granular backfill, not backfill. So it's got a few things here, but at the end of the day, we're only interested in doing the reinforcing inside. The other mistake students make is I say, how many bars are there? And they go, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, there's 25 bars. Okay, that's the answer. Rodger's already given it to us. See the wee donuts? No. You've got to work it out, and you'll actually find that that's not. Because this is a sketch, I've only sketched it. We need to work it out as engineers properly. This is very typical of what I used to get. Okay? I'm not a registered engineer. A registered engineer will come into the office, sort that out. Right? That's his design, her design, and you would have to turn it into working drawings and do the bar schedule. So it's not unheard of, that sort of thing. Yeah. This here is all granular backfill, which is kind of like a very fine material, made of rock. So this wall is holding that back. Right? So you've got a property and you put a retaining wall in, you're stopping anything coming any further. So you're looking at the face that's got the air. You don't have a retaining wall with dirt on both sides. Always one side's being retained. So if this was a retaining wall and I'm looking at it, then this would be near face and in the other room would be far face. Right? Don't have to worry about that on the other side. Looking down on the side. But will test. So do on the test. Okay. So the first bar we're going to look at is 1201. 1201 is the donuts. They're all over the place. All the way down here, all the way down here. So when you get a complicated brewing slab like this, we divide it up. And there is a reason for dividing it up because we've also got something different called a construction joint. Now, there is, you would have heard perhaps before of an expansion joint. And the chap at the back in the lecture this morning mentioned about concrete expanding contracting. We often have expansion joints just for that reason. I'll give you an example, a bridge. You know, when you come up to a bridge on the road and you look, your car goes pump, you go off the other end, pump, and you look, carry on. That's an expansion joint, and they fill that up with a bituminous type mix that takes up the expansion. Alright, so you'll get that thump as you go off the bridge. And that's why often in major earthquakes all around the world that go up and down, often you'll see a bridge is dropped and the road level's up here and the bridge is down here because the concrete was always separated from the other concrete leading on to, or the whatever leading on to the bridge. That's not an expansion joint, that's a construction joint. That means that they will pour this concrete here and they'll leave this reinforcing sticking up. And then when it's settled, the concrete's set, they'll come back, they'll put the shutters up there and they'll pour the next bit of concrete and before they do that, they'll join the reinforcing with the lap. And they'll tie that together in a way they go for the next one. You might have noticed on building sites sometimes you see these sticking up. Well, they used to just leave it like that. But now they put little cuts on the top. And the reason for that is exactly the guy that I was talking about this morning, was built about this wide. He used to tell us stories of men falling off buildings and landing on those and ending up like a skewer when you're eating chicken. And the cups apparently stop that from happening. I don't know if they do, but you can easily fall on them anyway, just trip on them. So it's the last thing that you want. So they protect those with little cuts. So we've learned something today about health and safety. What about that? So we're going to calculate all of those bar lengths, all of their dimensions, and all of their weight. So let's start with 1201. So we're going to have this bit, and the bottom bit. So in a nutshell, we're pretty much going to do 1201 here. We're pretty much going to calculate this bit, we'll call that A. This bit, we'll call that B. And this bit down the bottom, we'll call that C. So let's start looking at A. So to work out how many bars there are in A of those donuts, we have a distance of 2,500 from here to here. And we can't lie the bar on the construction joint because it's running that way and the whole bar won't get concrete around it. So we have to lift it up, the cover. We have to lift the cover up down at the top. So we end up getting a 2500 minus 50 minus 50. So let's do that. 2500 minus 50 minus 50 equals 2400. And we're going to divide that by the bar centres. What does it say at the top about bar centres? All bar centres are 300. So we're going to divide that by 300. And what do we get for an answer there? Sorry, that's not worth 8 marks. I mean half a mark. 8. Some of the bit too good in there. How about that? Okay, so that's 8 bars, right? You happy with that, Mr. Mathematician? 8 bars? Right? Wrong.
Or 2 was in the bottom.
It's 8 gaps. So you're going to get it wrong. Which means how many bars? 9 bars, right? Wrong. There's bars on the other side too. Times 2 equals 18 bars, right? How about that? You all happy now? You should be, because that's right, okay? So let's put 18 bars there. 18 bars. So we take A away, and we'll call that 18. Let's go to B. So when we do B, it's a bit different. When you go vertically, it's easy. Take away cover, take away cover. When you do B, it's complicated. And this is where it's going to get complicated in your assignment. I'll do a big blow up of this. So the bars go like this. And they go like this. Right? And the donut starts there. But what's that distance? Well, the distance is going to be equal to 2 times the diameter, 1 times the diameter, and the cover, CBR. And it'll be exactly the same at the other end to find the centre line of those bars. So we do it centre to centre. So let's put that into maths. What's 2 times the diameter? Hold on, is it diameter of that bar or that bar? It's actually the one that wraps around it, right? So that's 16 mil, so that'll be 36. 1 is 16, and the cover is 50. So that distance is going to be equal to, oh, well done. No, not half mark. I get that at 90 something. What's that? 98? Or 88? 88. 50 plus, big one? 98, yeah. And the other end is also 98. And the overall length from here to here is 2 meters. See up here? So it's going to be, the equation for that is going to be 2 meters minus 98 minus 98, and then it needs to be divided by 300. So have we got someone that can do the maths on that? Yeah, get it off. Oh, you need to calculate this time. But you did the first one so quickly.
6.01.
6.01.
Let's do the lower.
Oh, well, what did that equals 6.01? What did this come to here? 1802 or something, did it? Just testing. Okay, 1601, is that how many bars there are? Or is it how many gaps there are? Gaps, very good. And that means it's 9 bars. Times 2 equals 14. Right? Or is it right? I did say you were going to get it wrong. Now remember in New Zealand we over-design. Like I said this morning in the lecture, because of Christchurch and every other thing that's happened with earthquakes. Does that go up to 7? Or does it stay at 6? You think 7? Lots of 7s here. Fishing for a half mark. Okay, I'll let you out in misery. The rule is 0.2 rule. Please don't forget that, because in the test I've got 0.199s and I've got 0.2s. And every student puts their hand up and goes, was it up or down for 0.2? The answer is 0.2, it goes up. So if that was 6.2, you guys would have all been right. If it was 6.1999, it would stay at 6. Right, don't forget that. So in actual fact, that is correct. I'm just playing with you a bit, alright? So that's 14, so this becomes 14, and you have a look at the bottom, because that is 300, and if you take away the cover, that makes 250, and with 300 centres, you can only put 2 bars in there, so that's all it is, 2 bars. So the number of bars is 18 plus 14 plus 2, which equals 34, yeah? 34 bars, it's an alcoholic drink, isn't it? 34. Well, at this rate, we're still going to be here about midnight tonight. We've managed to fill in one number on the bar schedule. Yep. Okay, there is a bar mark there that we can copy, so 1201. And I've already talked about the location being each space, but we've also got the top and the bottom, so that's easily covered. EF, and top and bottom. Right? So you can have a combination of them all. You can also have each way, EW. So we haven't really got very far. We've managed to figure out one box. Anyone like to have a stab at how long that bar is? Going from here into the wall. I'll open it up to half a mark for a few seconds. You're allowed to answer it as well, but you won't get the mark. Very close. Unfortunately, it's 5 minus the cover actually. At 4.9. Yeah. So I better actually write that up here so that anyone, when you're copying the answer, leg equals 5 meters minus 50 minus 50, which equals 4,900. Now, here's another one for you, another half. Gee, I'm throwing away all these marks. Bar length is 4.900. Why is it 4.900 and not 4.4900? Everything seems to be in millimetres. We're drawing in millimetres when it comes to drawing. We're talking in millimetres. I've just been to do a millimetre calculation. I get over here and I suddenly put 4.9 on north. Half a mark.